these are inverses of each other. Anytime you have the natural log and the e, inverses cancel each other out, just like having 2x divided by 2. So if I had 2x divided by 2, multiplication and division are inverses, they cancel. So if I have the natural log and an e, they're inverses of each other and they cancel. And it's just equal to whatever the exponent is. And that is the property of inverses. It works the same way with number 49. It's just the opposite. So here I have the natural log, the e to an exponent. Here we have the e to the exponent of the natural log. But again, inverses undo each other. So if I had x squared and I took the square root, they undo each other. This is just also equal to x squared. So both of them are equal to x squared because inverses cancel. So it's more of just a property or an identity, we could call it. So inverses cancel each other out. Anytime you have the natural log and the e together, whether the e is raised to the natural log or the natural log of e raised to an exponent, they cancel. Josh? 100 and, you said 9?
Yeah.
So 109 says natural log of x plus 5, natural log x minus 1, and then you're subtracting the natural log of x plus 1. So Josh, where did you start?
I just kind of like simplified and put like the natural log of x minus 1 divided by x plus 1.
Yeah. So minus means you can condense them together and make it division. So x minus 1 over x plus 1. On the other side, we also have the natural log of x plus 5. And then when you have one natural log equal to another natural log, what happens? Yeah, we can just set the quantities after those natural logs equal to each other. And that's because the natural logs are the same base. So I can take the x plus 5 and set it equal to x minus 1 over x plus 1. But now we need to solve. Colin, to solve, you would have to...
First you multiply each side by x plus 1.
Right. I need to get that quantity out of the denominator. And the only way to do that is to multiply it. Again, right now it's division. So to get rid of it, I need to do its opposite, which is multiplying. And on the other side, we have an x plus 1. So these cancel, because now it's on the other side, I multiply it. And then, Colin, if you FOIL this side over here, you end up with?
X squared plus 6x plus 5.
And then the last thing would be to get this equal to 0. So anytime we have an x squared in there, setting it equal to 0, 0 product property. So x squared plus 5x plus 6. Factor?
Yeah.
How does it factor?
X plus 3x plus
Right. You said 3, sorry. I wrote 2 first. And then my two answers are negative 2 and negative 3. A lot of you had no solution with no work. It's a lot of work. Magical how no solution works without work. Why isn't there a solution? Dylan.
Because whenever you take and plug it back in, it makes a negative.
Yeah, so if I plug a negative 2 or the negative 3 back in, it's okay with the first one because negative 2 plus 5, negative 3 plus 5 is still positive. But when you plug it in right here, so negative 2 minus 1 is negative 3. Negative 3 minus 1 is negative 4. Or if I plug it in over here, you cannot take the log of a natural, or cannot take a natural log of a negative number. So neither of these work, that's why it's no solution. Not just because the back of the book says so. I really do look at your homework, even if it's quick. I know what to look for. Make sure you have work. I've been teaching for a long time. I don't have them all memorized. Mr. Cummings, he's got all his answers memorized. I don't have them all memorized, but I know what to look for. Good question to go over. So we're going to talk about solving equations today. In your packet, it should be the last page of your packet, and we're going to use this information, still solving equations, but we're going to apply it to applications. So a little bit of word problems with the solving equations. So we still use the same process. Oh,
You hate
it is, or it was. I don't know if it still is. It used to be in a green bottle.
She would toss it up.
Yeah. I don't know if it still is. I have to go.
Can we go on Amazon?
Maybe you could probably find it on Amazon. Maybe.
Yeah, Amazon Prime.
So the last section are called applications of logs and exponents, and there are these two compound interest formulas which we actually looked at a little bit in the first section because they were in the first section's homework a little bit. But these two applications help you figure out interest, and there are a couple different types of ways that you can calculate interest. There's something called simple interest, which is just your interest times your principal times your time. And then these two are pretty much how banks and loans calculate interest. So the first one is, N stands for compoundings. And like when your money is compounded, that's like you earning interest each time. So compounding means your new amount is calculated, which is how if you have a mortgage or if you have a car payment, that is, or your college loan when you get there, that's how banks calculate interest. So at the end of each month, you get a statement online. That's how it comes nowadays. But it'll show you what you owe, and then it'll show you on top of that the interest for that month. Or if you have a credit card, it'll show you the interest for that month. So interest is like when your money is compounded, you're getting interest on that. Whether you're gaining interest, losing interest, that depends on what you're doing with your money. So it says that my account has a balance of A, so that's the balance that I have. That's my end result, the amount of money. P is the principal. That's usually my initial amount. So initial amount I can spell amount right. And then the balance is A, so that's like the end amount that I have. The R is the interest rate, whatever the rate happens to be, as a decimal. And then the other variable up here that isn't defined would be T, and T would be time, yeah. And I guess N, it says the number of compoundings. So again, a compounding is how you're earning interest. Two different formulas because it depends on how the question is kind of asked and how your money is calculated. So if it's 12 times a year because it's monthly or quarterly, we would use the first option. The PERT formula, which is, it was a shampoo in a green bottle. I don't know if they make it anymore. But that would be if it's compounded continuously, which essentially it's every little split second that exists. It's just always earning interest on your money. So if you look at the first problem, a total of $12,000 is invested at a rate of 9%. Find the balance after 5 years if the interest is compounded quarterly. So like, just think about what everything means. So you're investing money. That's the beginning amount. That's what I'm putting in the bank or I'm putting in the stock market. That's my P. That's called your principal. The rate is 9%, but we need to write that 9% as a decimal. So as a decimal, 0.09. My time is 5 years. And then compounded quarterly. That's the N part. How many times a year would it be if it's quarterly? 4. There are 4 quarters in a year. I know, right? So if you plug everything in, a formula is just a plug and chug problem. You plug the numbers in, you work through the formula. So 12,000 bucks. We're using the first one because we're talking about a specific number of times we're compounding. Again, your rate is the decimal. We're dividing that by 4. equals to 0. So you can plug that all in your calculator. Remember, you're talking about money, so you need 2 decimal places to represent money. So you have your dollars and cents. After 5 years, how much money do you have? A lot? How much do you have, Josh?
$18,726.11.
Yeah. Does anybody know if you have like money in the stock market that your parents are saving for college? Yeah, it's probably now not as aggressive as it once was. But like that's how you earn money by placing it into accounts. Interest, yes. You earn interest.
2% interest.
Questions? So if you look at the second one underneath, this says how much money should be invested at 8.5% compounded continuously. So when you see continuously, that's the PERT formula. That uses the E. In order to produce a final balance of $100,000 in 25 years. So, like, say I have a goal, I want to have $100,000 in 25 years. How much money should I invest now? So that's what the question is asking. So the $100,000 represents the A. So $100,000 is my end result. I don't know what the principal is or what I should invest. I know the rate, 0.085, and I know I have 25 years. So you're going to have to take the $100,000 and divide it by e to the 0.085 times 25. Make sure you're using the whole value. Do not round. So use that entire number. Harry, do you know how much I should invest?
$11,943.30.
$943.30.
Yeah.
Kind of a weird amount to invest. Probably just invest $12,000.
Just exactly that.
Yeah, like that. I mean, then you have a little more. Any questions with either of those two formulas? So just make sure you're kind of looking to see what information do you have. Questions getting that number? So the third example on here is a little different because it's asking you to find an exponential growth model, and they give you the form of the equation for exponential growth, and that's this one here. So it's growing, it's increasing. This is what my graph would look like. So it says we have y equals a times e to the bx. So this one happened to be y equals 5 to the x, but similar. So my value here is growing. It's just using an e instead of using the value of 5. It says our graph passes through the points 0, 5, and then it also passes through the point 4, 1. So my y-intercept is at 0, 5, and then I have another point at 4, 1. Our goal is to find the equation. Josh, you okay?
Yeah.
Yeah, okay.
It's the one that's tickles.
No.
Yeah, okay.
So if we're trying to find an equation, thinking back to chapters 1 and 2 when we were trying to find equations, and it passes through specific points, and you're given the equation, in this case y equals ae to the bx. What is one thing that you can do when you have points and you're given an equation? Dylan? Plug them in. So Dylan, which point do you think would be a good point to start with? Because we have 2. 0 and 5. So let's take our equation and plug in our points. And you might as well use the one that has a 0 in it because you know at least the x value is 0. So y is 5. We don't know a. E is a number. Remember, it's not a variable. It's 2.718. I don't know b, but we know x is 0. What happens when you have e to the b times 0? Emma, what happens then? It becomes 1. Because this is a e to the 0 power Well, e to the 0 power is just 1. So now I know my a value is 5. So I know the coefficient that goes along with my base of e. So now I know it's 5 e to the bx. I at least have the a part. So that number in front actually represents the y-intercept of the graph. So what do you think you would do next? Plug in the other one. You're given 2, you probably have to use both. So if we plug in the second point using this new equation, now that we have a, y is 1. And we don't know b, but we know x is 4. All right, over here. So I have 1 equals 5e to the 4b. Our goal is to find b. Hannah, what do you think you do first to find b? How would we try and get the exponent by itself? So thinking of equations, what would you do first? Dylan?
Divide by 5.
Yeah, let's get the 5 out of the problem. So we'll divide by 5. All right, so 1/5 is equal to e to the 4b. Again, we're trying to get b. We want to know what that b is, which is the same thing as having an x. It's just a b. What would you do next? How would you solve this equation involving a base of an e? Emma? Yeah, put it into log form. There's nothing else I can do at this point. As an exponent, we got the exponent by itself, but there isn't any other step that we can do to keep it in exponential form to solve for that b. Emma, what would it look like as a log?
You have the natural base of 1/5.
Excellent. So the natural log of 1/5 is equal to 4b. And then to get b by itself, we're taking the natural log of 1/5 divided by 4. Emma, 3 decimal places. What do you get there?
-0.406.
So it wanted us to write an equation. We found a to be 5. That was actually the y-intercept. And then e to the negative 0.402x. So we had to do 2 things. Plug the first point in to get the a value. Plug the second point in, but then actually solve for the exponent. And when you solve for an exponent, you're converting it to the other form. Questions? So looking at the last problem on the back here. So we have Ethiopia. It was one of the fastest growing countries in the world. The nation is, it says, 3/4 of the size of Alaska. And Alaska is a fair size, but like, yeah, it is bigger than Texas, but it's still not the size of the United States. So it says in 1950, 20 represents millions. So this is a million. So in 1950, there were 20 million people. In 1990, there were 50 million people. Those will be points on the graph when we're talking about time versus population. So it wants you to see if we can find the equation that would represent exponential growth. Instead of using 1950, a 0. Remember, we don't actually use a year, we use a number to represent the year. 1990 would be 40, because it's 40 years later. So we're going to solve this the same way. We're using the same exponential growth model. Your y-intercept is always going to be your a. So the y-intercept is the a value of the problem. So once you know the y-intercept, take your next value and plug it in. then I would divide. So I have 5 halves, it's a nice color to write in. 5 halves equals e to the 40b. So your b value should be the natural log of 5 halves divided by 40. Josh, what do you have? So we have 20 e and then 0.023 x. The bell is going to be ringing, but if I wanted to figure out if 102 million would be right for 2015, what year, how many years later from starting in 1950 to 2015, what number would we plug in for 2015? 65. So I plug a 65 in, and I'd see, is that number 102 million? So that would be the way to answer the question. Plug the number in and see if it holds true. Questions? Anybody interested in doing 17 or 33? You have completed all yours. Yes. You'll do 17? Yeah, this is your third then. Have a fantastic day. So tomorrow we'll start reviewing.